My name is Andrea Ludwig, and my title tonight is Watersheds. We're all in this together, because quite literally, we are. Here at Relix Theater, we're in the Second Creek Watershed, in the larger Upper Tennessee Watershed, where there are so many complex social, economic, and environmental issues that communities have to deal with every day. So, what is a watershed? Technically speaking, a watershed is all the land area that drains to a common point. A simple analogy by Aldo Leopold, the father of the conservational movement, is everything is connected to everything else. And this is the essence of a watershed. And that makes the watershed the most practical management unit for decision making. In Tennessee, there are over 60,000 miles of streams, each within a watershed, and each watershed nested within a larger watershed. We as society are starting to understand how to use these watershed boundaries as management units for public policy, regulation, and natural resource development. First, to make effective policy, we must know how our activities on the landscape affect waterways. So here we have an example, the Big South Fork up on the Cumberland Plateau. As we see here, a true reflection of a natural watershed, where physical, chemical, and biological factors are all in a dynamic equilibrium. The landscape is covered with native vegetation. It's a very green aerial image here. When it rains in this watershed, the response in the stream is a natural processing of the added water. And the rainfall is absorbed in the watershed, and the storm flow into the river is gradual. Now let's compare this to a developed watershed. Here we are about to see the Knoxville metropolitan area in the Upper Tennessee River watershed, right where we are. This is a very different picture. It's a very gray aerial image. Our development in this watershed has changed the land cover and from the original forested condition to this new paved urban environment. We have put streams and box culverts and routed stormwater away from our buildings and structures as quickly as possible to the nearest creek. This hydrologic system is now unbalanced, and we can quantify this by measuring flow rates and sediment transport in streams and using ecological health metrics for biodiversity. And this is the larger problem. So how do we fix this? We research and develop new technologies to restore ecological function in degraded systems, like this stretch of Oostenaula Creek near Sweetwater, Tennessee. We used engineering principles to design and construct a new physical system that restores habitat and ecosystem services in this reach. And this leads to also a change in management, where now the farmer is using cattle fencing to protect his stream banks. But applications in the stream itself only go so far. The watershed is still the management unit, so we must look at the entire system. And we use a systems approach to understand and quantify individual components of the water balance. And we use a mass balance to understand changes in hydrology that are created by changes in these land covers. Then we take that information and engineer applications that mimic the natural hydrology that we have lost. For example, here we see downtown Nashville. This is the first green street in Tennessee. Stormwater runoff from the roads and rooftops is captured in this engineered facility called a bioretention bed, which allows water to infiltrate into the ground and be filtered for pollutants. We use other BMPs like green roofs and green development approaches, and these innovations allow us to continue to develop in watersheds while maintaining natural hydrology. And our research questions become, how effective are we, and how can we make it better? In Halls, in North Knox County, we are quantifying runoff and measuring pollutants transported from this typically constructed 1990s development, residential development. We are seeing flashy hydrology, as well as sediment and metals and other pollutants being transported from this system. We are working with homeowners to put in best management practices for stormwater, and we're going to continue to measure these components to see how effective we are with our best management practices. This mimicking of nature principle also applies in agriculture. Agriculture has the potential to pollute waterways with nutrients and sediment, and has been identified as the leading cause of degradation in watersheds across the country, most notably in the Chesapeake Bay area and the Mississippi River. So how do we innovate and reduce pollution potential? We monitor water quality and environmental conditions and select the appropriate best management practice for the problem at hand. Constructed wetlands are natural filters, and through water quality monitoring, we have quantified the rate of removal of nutrients and sediment and other pollutants in these built environments. This is the Little River Animal and Environmental Research Unit in Blount County, our new research facility doing animal and environmental science simultaneously at this unit. Here we've constructed 2 wetlands to treat agricultural runoff. We are quantifying the amount of sediment pollution retained by this practice and continue to research how pollutants like E. coli and viruses are remediated. While much of the research in watershed management is science and engineering related, the success of these applications relies almost entirely on social considerations. The triple bottom line of economic, social, and environmental considerations is applied to ensure we make sustainable decisions, recognizing that the economy is a function of the society, and the society is a function of the larger environment. As a faculty member with a majority extension appointment, I have the opportunity to work with citizens across the state. We work with communities to use technologies to minimize impacts on water quality while adding economic benefits. As in the case with this rainwater harvesting application, using free rainwater to irrigate landscaping instead of costly potable water. So watersheds are the ultimate multidisciplinary work. A group of faculty from 5 different colleges across UT has assembled to focus primarily on watershed work. Over the past 2 years, we've hosted 2 research watershed symposia and created a watersheds minor program for our students. We recognize the great need to prepare our students with the breadth of training in science, engineering, policy, and social sciences in order to find sustainable solutions for the complex problems at hand. This is the minor website that describes the program and lists all of the relevant courses, so please check it out online. Our approach to watershed research and training is integrated. We've identified this great need throughout our communities for answers to complex issues. And we are working to prepare the next generation of engineers, scientists, and planners with practical experience. Thank you, guys.